The memory is an storage integrated circuit. It stores the data bit by bit. Its characteristic properties are capacity, in MB, and access time, in nanoseconds. There are two different memories in its basic structure: RAM, random access memory, and ROM, read-only memory. RAM is randomly addressed, writable, and readable, that is, general-purpose memory. Its contents will be deleted when the computer is turned off. It has a wide range of uses. They are commonly used as central memory, cache memory, peripheral expansion RAMs, e.g., video memories, sound card RAMs, and CMOS. The memory is an storage integrated circuit. It stores the data bit by bit. Its characteristic properties are capacity, in MB, and access time, in nanoseconds. There are two different memories in its basic structure: RAM, random access memory, and ROM, read-only memory. RAM is randomly addressed, writable, and readable, that is, general-purpose memory. Its contents will be deleted when the computer is turned off. It has a wide range of uses. They are commonly used as central memory, cache memory, peripheral expansion RAMs, e.g., video memories, sound card RAMs, and CMOS. The programs that are being executed and the data to be processed by the programs are accessed by the processor in 1-byte compartments, which can be physically managed independently. Each cell has an address, memory position, from which the data in it can be selected, addressed, by the processor, and data can be placed in or read from it. Cell addresses are made up of ascending numbers beginning with 0. What is important is the possible size of the addressing, i.e., how many cells can be reached at one time. It depends on the processor. For example, a processor with a 16-bit address bus can access 2 on the 16th at the same time, -1, since addresses start at 0, i.e. 65,535 bytes. To write to or read from the memory compartments, the address of the desired storage location must be entered, which is received by the address register, MAR, memory address register, and its contents control the memory selection circuits. The data register, MDR, memory data register, temporarily receives the data to be written or read. The XT640KB had a main memory integrated, built-in, into the motherboard, which was later expanded to 1 MB with memory modules with the advent of IT computers. The main memory of newer PCs is not built on the motherboard, it consists of different removable memory modules depending on its state-of-the-art. Due to compatibility, 640 KB or less than 1 MB of this space has been left in its original form. The first 640 KB is called base memory, and the 384 KB area between 640 KB and 1 MB is called the upper memory area. You can manage more than 1 MB of memory as you like, but the base memory is divided into several different length sections that store only the data you specify. The number and format of the partition is not fully defined, it depends on the computer and the operating system that runs it. In a common structure, the base memory is the table of interrupt vectors, the operating system data area, the program area, the color AG of GA SVGA graphics data area, the monochrome graphics data area, the color CGA of GA SVGA text data area, the video card expansion area, the BIOS expansion area and the BIOS area. The table of interrupt vectors, starting from 00000000, contains the addresses of the interrupts. The BIOS system variables area, starting at 00400000, is reserved for BIOS variables, memory address identifiers. The operating system data area, starting at 00500000, contains the operating system variables. The program area, starting at 00600000, is used to store running programs. And the color AG of GA SVGA graphics data area, starting address A000000, the entire image matrix of the video memory on the color video card can be accessed through this area. And the monochrome graphic data area, starting address B000000, you can access the pixels of the monochrome screen. The color CGA AG of GA SVGA text data area, starting at B8000000, contains the image matrix of the text mode screen divided into characters. There are interrupts to the expansion ROMs on the video cards in the video card expansion area, starting at C000000. In the BIOS extension area, starting address C8000000, you can access any extended BIOS Plus data. The BIOS area, starting at F000000, contains BIOS information. The memory modules always work with the clock signal of the motherboard, the memory corresponding to the motherboard must be used. There are several types. In the past, DRAM chips were mounted directly on the motherboard. Later, the single inline memory module, SIM, which can only be used in pairs, and then the dual inline memory module, DRAM, which is a knife connector with a knife connector that contains multiple memory chips. The 286 and 386 and older 486 motherboards use 30-pin page mode (PM) DRAMs with access times greater than 70 ns, up to 1 MB of modules, and error-prone parity bits. Depending on the type of parity bit, it adds the number of bits one of the transmitted data to an even or odd value. If a bit is corrupted during data transmission, the number of individual bits will not match between the sending and receiving devices due to the addition, i.e. a parity error will occur. It is unlikely that multiple bits in a transmitted data will be corrupted, so this type of control can be well applied, although it slows down memory performance. Newer 486 and Pentium motherboards require 60 to 70 ns, 72-pin fast page mode (FPM) DRAMs, which typically have 4, 8, and 16 MB capacities. They can be with or without parity checking. Memory modules with an access time of 60 ns can only be used on 66 MHz motherboards. Pentium and Pentium-compatible motherboards can also accommodate 8 and 16 MB extended data output (EDO) DRAMs with 50 to 60 to 70 ns access, which do not have a parity check bit but include an internal read-only memory. Depending on the clock speed of the latest motherboards, 66 MHz, 100 MHz and 133 MHz, 168-pin synchronous DRAMs (SDRAMs) are used. Another version is the Error Checking and Correction (ECC) SDRAMs. Their capacity reaches up to 128 MB. Later, Double Data Rate (DDR) SDRAM was introduced, which utilizes both the rising and falling edges of the signal, doubling the data transfer. The latest memory is the Virtual Channel (VC) SDRAM, which contains 16 128 or 256-byte static memory channels, virtual channels, speeding up its operation. The cache memory is a few KB in size, fast, approx. It has an access time of 10 ns and is therefore used to send and store data quickly. Operationally, it is located between the main memory and the processor. When the processor wants to access a piece of data, it first addresses the cache, and if it finds it there, it reads it; if not, it reads it from main memory through the cache. The data, along with its address, remains in the cache until it is full. There are two types. The internal cache, on-chip cache, is built into the processor. The external cache, off-chip cache, is a separate storage. The size of the external cache, because it is separate, may be larger. CMOS, complementary metal oxide semiconductor, is static RAM designed to store information about the presence or type of embedded hardware, date, time, type of hard disks and disks, basic type of video card, and system shutdown in the event of a failure. This is solved by connecting a lithium battery to it, which provides power for up to 10 years. The information stored in it can be set or read in the login setup. This information is required by the operating system and near-system programs. Switches could be set with switches in the first PC, but at computers already contain CMOS. This information is required by the operating system and near-system programs. ROM is read-only memory. The data is written to the ROM at the factory, burned in a special way, and can be read. Its contents are not deleted, even when the computer is turned off. No power supply is required. There are several groups, some that can only be loaded once during production. These are normal ROMs, some that can be uploaded but not deleted by the user once. These are PROMs, programmable ROMs, some that are special can be erased by UV light. These are EPROMs, erasable PROMs, and there are those that can be erased electronically. These are EPROMs, electronically EPROMs. The basic input-output system, BIOS, is software that contains software that communicates between the hardware and the operating system. A ROM that contains information about hardware devices on your computer and services that manage your hardware. All BIOS services are invoked. The BIOS data is stored in memory by the processor when the machine starts up, starting at F000000, and can be accessed by programs. BIOS interrupts are located at the addresses specified in the memory interrupt vectors table. There are a total of 12 BIOS interrupts. Of the 12 interrupts, 6 manages the peripherals, 2 checks for the presence of devices connected to the computer, 1 deals with the time and date, 1 prints the contents of the screen, and 2 connects to another area of the computer, starts the power on routine and ROM basic. When you start your computer, the startup routines are performed using the startup programs in its built-in ROMs. The reliability test starts, which examines the functionality of the control cards, and then the memory. The initialization process then begins, which sets the default value for the interrupt vectors and checks to see if the hardware information read from the CMOS matches the responses of the queried hardware devices, and then checks for ROM extensions and, if so, controls. Temporarily passes it onto them so that they too can initialize themselves. Then the boot process starts. Bootstrap is a short subroutine that can be used to load a program from the selected storage. It attempts to read the boot sector 0, and, if successful, passes control to the program stored in the sector. The job of a program is usually to load the rest of the program, usually the operating system. If you cannot read the boot sector, you will start ROM basic. ROM basic is the basis of the BASIC language and contains most of the commands. Its job is to start the machine without an operating system, and if it contains a base program, it will start it. If not, it will display an error message warning that there is no operating system on the machine. ROM extensions can change or prevent booting. BIOS versions released after 1982 can be expanded with new, different or modified routines. To do this, an EEPROM must be placed that contains the new features. Newer motherboards have an EEPROM, flash memory, into which new data can be written with its own special program. Different BIOS is produced for different types of motherboards. The 3 best-known versions are AMI, American Megatrend Incorporated, Award, and Phonix BIOS. All 3 versions handle peripherals in the same way, showing only differences in drive types, memory management, timing transfer, and some user functions. Data storage and memory. Top is the data, to be recorded in hexadecimal format. Bottom is the location of the data in memory. Cache memory between the processor and main memory. Left side is, the data is in the cache. First step, addressing of cache. Second step, read of data. Right side is, the data is not in the cache. First step, addressing of cache. Second step, addressing of central memory. Third step, write the data from main memory to cache. Fourth step, read of data.